Project 3.4.2, SAR, ADC, R2R ladder DAC by ADC stipulated. The purpose of this project is to create the second iteration of the SAR ADC, that being the R2R ladder DAC, which converts a digital input into an analog voltage using precise resistor network, a sample and hold that captures and stabilizes the input voltage, and a comparator which compares it to the output of the R2R ladder DAC. One fundamental concept found within the sample and hold comparator and R2R ladder DAC portion of the SAR ADC deals with the introduction of negative voltage and how it is incorporated in such circuit. Negative voltage is not fundamentally different from a positive voltage, as both represent potential energy relative to a specific reference point. When connecting a reference point and voltage together, conventional current will flow from the positive node to the reference node, acting as positive voltage. If the same situation were to happen but the circuit node was connected to negative voltage, conventional current will flow from the reference node to the negative node. Negative voltage is able to be introduced by taking two 9-volt power sources and connecting the ground of one into the positive terminal of the other. Another key idea that is new to this course has to deal with an R2R DAC, referring to a resistor ladder network consisting of resistors of two values, R and simple enough, 2R. Using the two different resistor values, a ladder is constructed. The ladder results in a voltage output of a fraction of a reference voltage depending on the bit value of a digital input, which is all you need for digital to analog conversion. As you can see in the demonstrated video, the voltage drops by a significant voltage for the first dip switch, then for half of that for the second dip, and so on. An R2R ladder provides a way of converting digital input voltage signals into an equivalent analog output. Moving to the right of the circuit, the LM393, the chip directly wired to one of the resistors found on the ladder, acts as a comparator used in the sample and hold section of the SAR ADC, specifically comparing the voltage from the DAC to the sampled analog input voltage. Moreover, immediately following the LM393 comparator is the LF398 chip, which is connected. The LF398 is a sample and hold amplifier that will take the inputted voltage and, when activated, will store this said value until asked to release and recalibrate to the new input. If the DAC is lower than the input, the comparator outputs a high signal instructing the SAR logic to set the current bit to 1. If the DAC output is higher, the comparator outputs a low signal, causing the SAR to clear the current bit and adjust accordingly. This process will continue until the digital approximation has reached a point where it is the closest possible representation of the inputted voltage. The LF398 sample and hold amplifier remains steady during the conversion process, preventing changes in the voltage level that could cause errors when comparing voltage values. When the chip is activated, the LF398 follows the inputted voltage, allowing it to change dynamically. However, when switched to hold mode, it will read and hold the instantaneous velocity being supplied through the use of an external capacitor. The voltage held will remain constant, ensuring the comparator functions accordingly and only changes when the chip is switched from hold to sample. The process of holding the voltage ensures the comparator and DAC operate on a fixed reference throughout the successive approximation steps. Thank you for taking the time to listen to my video on the SAR ADC, R2R ladder DAC, sample and hold, and the comparator.